All right, so for this part of the presentation, showing you sort of the comparison between the wild type and mutant version of our protein, our gene of question, I figured I would do something different and show you this via video. This is a software called Pymol, and it's something that I use a lot in my own research that involves a lot of molecular dynamics and simulations. So this is from a paper studying Leopard syndrome. This is the crystal structure of the protein product of our gene in question, PTPN11. The protein is SHP2. It's a protein tyrosine phosphatase. I'm just going to walk you through what each section of this molecule is, and then I'll show you what gets mutated. So here in orange is the catalytic domain. This is the PTP domain. This area in green right here that I'm circling with my mouse is the N SH2 subunit, and down here is the C SH2 subunit. Just going to do a quick spin around, show you the molecule in all of its glory. And you see this part that I've colored in blue is very important. This residue right here, it is normally a tyrosine, and I've made it its full molecular stick model instead of just the cartoon. But so that is what is mutated. But keep in mind, look how open this conformation is. It's ready to take something in and cleave that phosphate off. So next, let's move. So this is the mutant version. Let's make sure it's recording. Yes, it is. Okay, so same basic idea. So here in green is our N subunit. Down here is our C subunit. Here's our catalytic in red. And as you can see here, we have changed this residue, this blue residue, into a C or a cysteine. And what happens is, I can show you a side-by-side in a second, but the molecule becomes much more condensed. It goes into its closed conformation. It is much less open. Let's see if I can, yeah, let's do a little side-by-side. So here is our wild type. Let's just flip it around to the back. So you can see it's much more open compared to our mutant. You see how all these beta barrels are much closer in together. So that is physically what is happening when that mutation happens. You can see the difference. And then just from the literature, so this mutation that happens is a Y297C mutation. What happens is, when that happens, it weakens the interaction between the N domain and the PTP domain, and it causes this closed conformation to occur. And one interesting that happens is, so in Leopard syndrome, the catalytic activity of the enzyme goes away completely. But the literature has shown that even in this closed state, this molecule can gain some new functionality in the closed state, and it has been shown to promote a sustained ERK1 and 2 activation. So that's very interesting that this closed inactive enzyme can actually go on and produce gain of function phenotypes that you see in Leopard syndrome. But yeah, just figured that would be a little bit more interesting than just linking some static pictures. You can see the molecules in their full glory here.